I'm based in Austria, so I'm from Vienna. You might have heard based on my accent already. Yeah, I did development for most of the last decade, very many different technologies, native stuff, Python, Java, all that sort of thing, and a lot of web actually. And now for the past 2 years or so, I've done mobile development and full-time implementation for about a year now. Okay, and now my presentation today is about Kotlin Multiplatform, or Kotlin. And as an iOS developer, you might ask, what is he doing talking about Kotlin on an iOS meetup? It's not what you would expect. And I initially thought, well, I could also talk about Swift and Swift UI, but most of you actually know that probably and know the most recent developments, or at least following along. So I thought I'll talk about something that's not as widely known for iOS developers, and that's Kotlin Multiplatform. And my background for Kotlin Multiplatform, or why I find it so interesting personally, is because I have this strong web background. I'm very used to, and don't get me wrong, like web has many mistakes and it's not the most fun thing to work with. But what it really got right is that full stack approach, in my opinion. So I have really, really good experience with full stack team in web because you can so flexibly relocate resources across developers. And you can like really adjust to your needs without switching people around, and you don't have this problem of knowledge silos where like the backend devs know their stuff, they really know the domain, but they don't communicate their endpoints to the client-side devs. So all these things, they are really good at full stack teams where everybody knows the code and people can really work on features instead of platforms. And so when I started mobile development, I was naturally kind of attracted to these cross-platform frameworks where it also gets you this similar kind of feeling, or at least they promise you that. Especially React Native, you could again have a full stack team working with JavaScript in the front end browser. But you know, every one of us by now knows those cross-platform frameworks, they don't hold their promises. It doesn't really work that way they tell you. You don't write their code once and it runs everywhere. At some point, you'll start writing those native plugins, snitching in Java code and Swift or Objective-C, using different IDEs than you're used to. And it really feels kind of alienated in these technologies. So that's what Kotlin Multiplatform tries to do different. So instead of having yet another cross-platform framework where the UI is written once and then compiled for both platforms, and the business logic is basically a bit spread between plugins and JavaScript or whatever, Kotlin Multiplatform tries to embrace the platform specialities and only shares those parts that should be shared. So that means it doesn't want you to share your UI. You will be using native technologies, Swift UI or Jetpack Compose on Android, to write your UI code. It doesn't want you to share the code for, I don't know, biometrics on your platform or accessing a keychain on iOS. That is platform specific, and Kotlin tries to keep that platform specific. But what it does want you to share is the business logic, the core of your applications, the business rules that actually build up the domain, because those aren't platform specific. They are business specific, company wide, and they then also contribute to aligning the platforms. So by being able to share, I don't know, on mobile, it might be the view models, might be your data caching layer, your database maybe, being able to share these parts between platforms, you can align the platforms, align the developers, and share knowledge, and still embrace the native technologies you're working with. And of course that sounds kind of fancy, but how does it work after all? So the structure of a KMM project in general, especially for small projects, look like that. You have a shared Kotlin base, and it really depends on your needs, how big that is. For new projects, it might be very small, especially for people playing around and only adopting KMM. Might only be, I don't know, the API layer, but it could be very big. So in our case, VitraCat, we share basically everything except for the UI. And then you have native applications written in iOS, on Swift, or Android with Kotlin again. And they plug into that Kotlin framework. And well, for Android, it's kind of obvious how that could work because both is Kotlin and the build systems are the same, but how does that work for iOS? And that's where another point of Kotlin comes into play, and it's that it compiles to native technologies. So it doesn't, like all the other cross-platform tools, bridge between whatever JavaScript or C# and your native technology, but it actually compiles to binary. It does that through a compiler chain that's called Kotlin Native. So it really gets you a dot framework, an Objective-C framework that you can then use from within your Swift code or wherever you're using it from. And As a side note, it also does that for JavaScript, so you could actually work on many platforms with Kotlin. And yeah, I think that's that. And now what I said initially was that Kotlin embraces the native technologies. And it not only does that by allowing you to use the Kotlin code but then write your UI natively, but it also allows you to write platform-specific API code in Kotlin. So it does that by providing a thing called source sets. And for example, you have 3 source sets. That means common main, a source set targeting all your source codes or all your platforms you're working on. And then you can write specific code in iOS and Android main. And that code can actually use platform-specific libraries. So you could use a UI kit library, or maybe, I don't know, the keychain on Android. I'll show an example in a second. The keychain on iOS and encrypted share preferences on Android. And all that while still being Kotlin, still working with the same IDEs, still having code completion, and everything else that you'd expect in a modern language. So that's a really, really cool approach in my opinion, and that's actually what differentiates it, in my opinion, mostly from the other cross-platform frameworks. Writing the UI natively is really cool, but that feature is the most important thing. So how does that look like in code, writing such things? In the common code base, you'll write an expect declaration. And that means you define an interface for your code that you want to use for whatever feature it might be. And then on each platform, you write an actual declaration that can then, as I said, use the specific libraries that you need for the implementation. It could also not depend on libraries. It could just be that the code is different. I think in the live demo, we can see that afterwards, where we just have different implementations for iOS and Android. But in general, it's very useful if you have specific implementations. And one example from our code base is encrypted storage. It's obviously a bit slimmed down here. But in general, we use it for storing encrypted items in your device. That is the keychain on iOS, that is encrypted share preferences Android. And to be able to use it from common code, we have a class that's called encrypted storage. And you can see it looks very similar to an interface after all. And that's written in common code. And we then have corresponding implementation in both Android and iOS. And obviously, as you can see, those implementations look very different. And what's really cool, in my opinion, is that on iOS, the Kotlin standard library comes with platform bindings, I think they call it, that allow you to directly call Objective-C code from iOS main. And Kotlin does that by understanding that this source code corresponds to iOS or any other platform you're targeting, and basically allows you to access the corresponding functions in only that part of the code. And that means you get code completion, you get syntax highlighting, you get proper compiler errors in those specific source codes, and still are able to use the normal platform features. So yeah, really cool in my opinion. And now I want to briefly show you how that looks when you actually apply it. So how we structure our code base, that's basically fully done in Kotlin Multiplatform. And by doing so, we are able to share a lot. So we usually it's very typical that you start by sharing your repositories and maybe your API layer, and then maybe you draw out the use cases from your view models. But we decided to go one step further, and we decided to even include the view models. Because to us, the view models are really, on the client-side application at least, one of the core parts. So we also wanted to be able to share those. And then we only have a small UI part, and I will show you a code sample how that looks in a second, that is platform specific. And even that looks really similar because of SwiftUI and Chapter Compose and the similarities between those technologies. And then on the other direction, the backend would be basically visible here, and that's why I colored the API differently, because we didn't even just share the code on mobile, we went as far and started sharing code pieces with the backend. So our models, our DTOs, are written once, and if we zoom in on the API, you can see that the API package actually contains parts that are client-side and parts that are back-end side, and share their DTOs with them. And so the endpoint and the corresponding client for that endpoint, they are directly next to each other in the code base, making it really hard to make a mistake there. Like the DTO is typed, it's a class, and the both corresponding implementations for the backend and the frontend are next to each other on client-side. So it really is a convenient way to go around the code base, avoiding errors, but still don't having to put in any code generation features or anything else that's putting in additional sources of error actually. So yeah, that's how we are using it, but now towards the end of my presentation, I want to show you some code. So this is one example of a very slimmed down sign-in view model. And it is written in Kotlin, it is written in common main. There's not too much to say about that. Maybe just to add to that, the view model class is platform specific. So it's just a base class that's an expect declaration. We use the Android native view model specialities on the Android implementation, and on iOS it's a very custom one. But we have one view model, and all of our view models basically inherit that without having to write any or taking care of anything actually of the life cycle or whatever in the common code or in each view model. So that's really cool. And then, of course, we have the iOS app, and that's now SwiftUI, and it directly integrates with our view models. We have dependency injection in place, post a view model from the common dependency container. We have a few custom annotations that allow us to get the state from the view model, because that's still Kotlin, it's not a publisher. We have to convert it to the combined framework publisher that we want to use there. And then we just have a very simple screen that displays parts from the view model. And as I said, the cool thing is for me that also this looks very similar for Android. So if you compare the Android implementation of that, it does look very similar. You can see the correspondence between Android and iOS. And to me, that comes back to what I said initially. It allows the teams to really share the knowledge. That this screen is so similar, if an iOS developer has an idea of improving that screen by pulling out a common component, it's very likely that we can use the same common component on Android. Since the design systems are like similar at least, then the layouts will be approximately the same. You can even apply the learnings we have across the UI frameworks, even though we are writing the implementations once. And then, of course, it goes a lot further with the view models and everything, where we write the tests once, we write the view models once, we have the same repository, we have the same database on both platforms, we have the same API on both platforms. So it really allows us to share our code base. And yeah, what should I say? It still is allowing us to access native technology. So really, really cool in my opinion. And for me, it really has changed the way we develop our mobile applications, because we don't split our teams according to the technologies we work with anymore. So even though we hire obviously iOS developers, we hire Android developers, we hire backend engineers, they all work in a very, very, very similar stack. So everybody uses Kotlin one way or the other, and everybody sees everything. And for us, that means that our developers can feel a lot of ownership about the features that they are building. They have to understand the full flow, and they're also reviewing the PR from the backend side. And because they know Kotlin, they can read it. And then they can directly use the same, basically edited source code and use their view models in the client-side implementation. So to us, it really has helped every developer to feel a sense of ownership, and it's a really nice feedback that I always get from new developers joining. They say, yeah, it absolutely feels different than before, and we don't have that knowledge silo from the backend and the client side anymore. And we see the backend domain knowledge that we have, and we understand it, how we translate it to client-side code. So it did really change the way we have this team structure, and to me, it reminds me a lot of my initial dream of the full-stack mobile developer. So it really comes close to that, even though, as I said, we have step-rated technology somewhat, because nobody is an expert at everything. And yeah, maybe to summarize our learnings briefly that we had with Kotlin Multiplatform. So over the past month, we've come to the realization, or the past 6 months, let's say, that it's really young. So if you're trying to adopt it, be prepared for spending quite some time on very seemingly simple things. One good example is the M1 in that laptop. It took me so long to get it building. And just today, I tried to create an example app purely based on the initial project wizard they provide you. It doesn't work, it doesn't build. it's just really, really a lot of hassle to get started. And of course, that also comes then with many breaking changes when a new version comes out, dependency incompatibilities, having to wait for all the dependencies to update, all these sorts of things. So that is definitely a problem. The second one, and that's a bit specific, is that concurrency is a big thing in Kotlin, but when you go Kotlin native, you have to take care of the memory management. You don't have that JVM garbage collection thing anymore, so you have to somewhat keep in mind what your objects are doing, and there are suggested ways to work around that, but it still can cause crashes. And I think especially on iOS, it's not very usual to have crashes when working with Swift and SwiftUI. It's very hard to make that sort of mistake. with Kotlin, it's possible again. So you have that native interrupt in between, and that can cause errors. You can work around that, obviously. And once you got your structure in place and your best practices, you know, but it did cause us more than one crash, I can say that. And yeah, the last time, and that's specifically written from an iOS perspective, it gets time to get used to it. So, whereas for an Android dev, in joining our team, they are basically onboarding in 2 days. It's Kotlin, it's the same IDs they are used to, everything's like they want it to be. For an iOS developer, it's more or less the opposite. Even though we still onboard into Xcode, at some point we transition them, or it depends on the person after all, but we really suggest using app code as an ID, which is a JetBrains ID. Reason being, I will show you in a second, it does have code completion for both Swift and Kotlin, and it even allows you to, for example, click through to the Kotlin implementation from Swift and find usages for Kotlin code in Swift. So it really is a really good ID for that. And in general, I suggest to anybody who does Swift UI development, at least try JetBrains IDs. They are really, really good. Maybe not the best for iOS development. Well, you could try. But, well, so what we learned is for iOS developers, it's really hard, or a lot harder than for Android devs to get onboarded. And it just isn't the usual setup that everybody has. So, yeah, that's that. I think those things will get a lot better in the future. So as I said initially, it's still young. The tooling is evolving quickly. New versions are coming out basically every week. And by every week, I mean every week. We test literally every beta version of every tool just to be able to have the latest features. And I think it will be a really, really promising way of working in like the next few months. So I think now that the tooling is or the technology is stable, the tooling will come soon. And that's what's still missing. And yeah, so maybe a question that I keep asking myself retrospectively a little bit, and I think we discussed it internally a few times, was it actually worth choosing Kotlin Multiplatform over, I don't know, a native implementation or a fully cross-platform implementation? And I'd say absolutely. Because for one, even though it sometimes we are really struggling with, as I said, seemingly simple things, it is a really cool feeling working on such a cutting-edge technology. I'm saying this as a developer, so it might not be the business perspective. But on the other hand, it allows us to have confidence in our code base, in the scalability of our code base, mostly. If we would have chosen a cross-platform implementation, we wouldn't be sure to be able to scale infinitely. Like, everybody knows the stories of Facebook, Airbnb ditching React Native, or the other companies going away from their cross-platform technologies, and eventually switching back to native development. That's why we initially chose to go Kotlin Multiplatform, even though it was really young when we started working on it, because we wanted to have this backup for using native technologies, but still being able to share our code base and work fast with a small team. So I think it was the correct balance to make, but it did cost me a few gray hairs, I guess, even though I'm still young. Yeah, and that's it. A small note we are having, a small fintech startup. So if you're interested in joining our team, we are growing fast and we really need iOS developers who are open to work with Kotlin Multiplatform. Yeah, I think that's it. If you have any question, feel free to ask. And should I quickly switch to the live project or do the questions first?
Go for it.
I can show you quickly how a project structure in KMM looks like, just so you believe me that it's pretty cool when you work with app code. So this is the initial project that's generated by the project wizard. As I said, I didn't want to pull in anything crazy because it gets hard to explain. But in general, you have a shared code here, which is purely written in Kotlin. And it does, in this case, only contain a greeting that's platform specific. As I said, we don't use any.
Just wait a second.
After
the lights.
And I will also increase the source code.
Doesn't work.
You've tried every button.
I tried, yeah.
We can change the background of the project.
Do you want to change the background to white
I will see if I can do it.
and zoom a little bit in?
Yes.
Sorry, guys. I don't know.
Can you switch? Better?
Much better.
Could you zoom a little bit
Yes,
in?
I can try it. Even
Ah, amazing.
Okay, so that's the expect declaration. It's written in Kotlin, and it is only here in the common code, in the shared code. And the important part for me is quickly showing the iOS app. I think, yeah, it's written in Swift UI, that's the initial one. And I hope we can see it. But basically, we are calling into Kotlin code here. So this is the class from Kotlin that we just saw, greeting.greeting. And it's direct access from Swift with full code completion. And the cool thing, if I now command click on greeting, it actually brings me to the implementation. So this is the common code for the greeting. This is the platform specific implementation. And the last missing part is then the iOS and Android specific implementations. And it's a bit laggy with this one. So what you can see here is we are importing the platform, which is always the prefix for a package that's platform specific from Kotlin, the UI device into Kotlin, and it's no dependencies added. That's just the Kotlin standard library. It provides you bindings to your specific platforms, and we then get the current device system name, current device system version. I can also briefly show you how it looks on Android, just to believe me that it's different. On Android, there is not such a cool way to access the version, so it's just android.os.build. Yeah. So that's basically Kotlin Multiplatform, and that's why I'm always saying use app code to our developers. It does have amazing refactoring capabilities and everything, but the cool thing for us is we can show the whole code base in one IDE, and you don't have to switch when editing different parts. You don't have to know the key bindings of two IDs and everything. It's just all in one. And technically, I could now also run the iOS app, but as I said, I'm on the M1, so it does require quite a bit of setup to get it running on an M1 chip. Yeah, and also it's just a greeting showing on the screen, so nothing too fancy. Okay, and if you have questions to the example, I can also show build files or anything if you want to.
Yeah, I can run a build.
Excuse me?
You can run a build.
I can run the build, but it doesn't do a lot. It's really just quickly building and then saying it doesn't work. Yeah, because I actually have build cache, but it says the architectures are not matching because I have the M1. I can open it in Xcode maybe, and while we load, okay, no, I cannot because it's.
Sorry, so why is it not building? I'm not sure. What does the chip has to do with the?
Processor architecture.
Yeah,
Rosetta
process.
maybe helps, no?
Excuse me?
Rosetta, if you're running a Rosetta.
If I run it, exactly. So I always have Xcode running in Rosetta right now, and that's why it works. But again, it's a new project, so I would have to do a bit of setup to get it open in Xcode. Basically, I already added the source set for Kotlin for RM64 simulator. That's what you would need here. I hope it's visible. So I tried quick patching it, but I think one configuration, I'm not sure which one it is still missing. So it's possible with Kotlin 1.6.10, but yeah, I'm not sure what the setup. The project setup wizard doesn't do everything that's needed to be done just yet. So I tried to add the target. Basically, that's how Kotlin Multiplatform works. You add the specific targets you're building for, and the iOS simulator for RM64-bit architecture is one of them. That's the one that also runs on the M1 chip. But for whatever reason, it doesn't understand the correspondence between the actual iOS app architecture and the common source set architecture. It says the platforms are not compatible, even though they are. Technically, they can be built, but I don't know why.
It's probably because it thinks it's building for the simulator, so it should build x86.
Exactly. It's built, yes, exactly. It's doing exactly that, and there is configuration things that could by now fix it, but yeah, it just takes a bit of googling to figure it out. And luckily, it's a one-time setup. That's why I forgot it again. I don't do that too often. Okay, so now questions.
You go for it.
No, no, please.
I have way too many questions.
Okay, for memory leaks, are you using the Xcode instruments?
It's not memory leaks that are causing the problems. So with Kotlin native, they have a very specific memory management in place to prevent memory leaks or race conditions. And what they do is when an object is accessed by multiple threads, it gets frozen. Once you have an object that's shared, it's completely frozen in memory, and you cannot change anything. You cannot change any properties anymore. And that by itself doesn't make a lot, doesn't cause any issues. But if you have, let's say, a view model class, and any method in that switches to a different thread for doing anything, which is obviously a common use case, you have to ensure that inside the view model, the thread switching is really contained without accessing any outside variables of that view model. Because as soon as you access one of these variables, the whole view model class is frozen and you cannot mutate any state anymore. And that's what causes the crashing. Because once you try to access that sort of memory, it says frozen memory exception or something like that, and you cannot do anything. So it's not memory leaks that are a problem, it's accessing memory from different threads. And Kotlin team is working hard on that because they know it's a big issue and many teams are complaining. So with the newest Kotlin versions and new memory model is available, that lightens these restrictions a bit. And you can now enable it. We didn't yet, it's experimental, so we don't want to use it in production. But you can now say, okay, it's possible to mutate state for multiple threads and I take care of the race conditions. Their idea was, I think, they didn't want programmers to have to think of race conditions, but now you have to think so much about object ownership that it's even worse probably, so, yeah.
And also, is there any technical reason to choosing the Swift UI, not UI kit?
No, there's no technical reason.
Just the latest technology.
Exactly. The reason for us was we are also using Jetpack Compose on Android, and as I briefly showed for the screen examples, it just looks so similar on Android and iOS with the declarative technologies. We wanted to have that knowledge sharing between the platforms again, and that's why we went for these declarative UI frameworks. And also, like really, again, one of the main driving decisions for that stack as a whole was future-proofness and scalability. And I think Swift UI is the framework that will have the most backing from Android, from Apple ongoing. So if you want to choose a new technology now, I think it should be Swift UI if it should be sustainable for a long time.
Thank you.
Like I said, I have so many questions, but I'll be a good team player and I'll contain myself to two. So the first question is, you mentioned bindings. Are those bindings automatic from Kotlin? So say if I want to access a new API that Apple releases, is it available day one, or the community has to write those bindings before it's available? And conversely, if I want to use an iOS native framework developed by some third party and I want to bring it in, do I have to write the binding myself or use a community binding, or is it automatic?
So for the first question, I'm not 100% sure, but I'm pretty sure it's not generated. So you might have to Google it, but I'm pretty sure the Kotlin team writes an somewhat interface implementation, at least around the API, and that's basically a slight answer to your second question as well. They only bind to Objective-C implementations for now. So everything that you want to use needs to have an Objective-C API. That obviously reduces or removes some possibilities. Again, Kotlin team is working on adding Swift support as well. They want to be able to compile to many different languages. But for now, it's only Objective-C. That means no UI kit, no cool keychain wrapping libraries. That's why I showed the example with SegItemAdd. I think I wouldn't use the native Objective-C API that the keychain provides. I would go for a Swift API. It's not possible. And lastly, yes, it is possible to use different libraries, but since it doesn't have Swift support yet, it also doesn't support Swift Package Manager, so dependency management is co-quartered, if you want to do it. That's a downside. Yeah.
And do you find that it's harder to hire iOS developers because you're using Kotlin?
Well, it's hard hiring iOS developers, that's for sure. If it's because of that, I don't think so, actually. It's harder to do the onboarding, and it's a lot harder to get them to be as productive as our Android devs are. We want them to be on the same level, and I think it's not yet agreed with like the industry, everyone who's using Kotlin Multiplatform. It's still, some are like basically isolating the iOS devs a bit more. We are trying the opposite approach and really integrate everybody into the whole code base, but that means a lot of onboarding, a lot of pair programming with Android developers, people who know Kotlin well. But for the hiring specifically, I don't think anybody, Sophia is our hiring manager, correct me if I'm wrong, but at least at my level, nobody ever rejected because they said we don't want to use Kotlin. If it was more like if it had any impact on their decision, I think it was more like a pro, because basically most developers are interested in expanding their career skills. And if you say, hey, you are able to learn Kotlin here, we provide you with the infrastructure and every material that you need for learning it. Nobody says, no, I don't like new technologies, I want to stay only Swift.
because Objective-C did it.
Yeah, that's true. Yeah, but yeah, we try to pitch Kotlin as a cool language. Okay, any other questions?
What's the debugging experience?
That was my-
Um, Important question. So and so. It is possible, especially with Xcode and also in Xcode actually. You can even add a plugin to Xcode that allows you to debug Kotlin files from there. In my experience, the worst thing is that because of our code base and the size of it, it's becoming pretty slow. I didn't yet test with the latest version of Xcode, I think it was released today, where they claim to have added better support for that. And as I said, I'm reading through the issues on JetBrains every day, so I hope they will improve that a lot. Swift debugging works as usual, and also going into Kotlin files works, but you have to wait for some time to see the current status of all the variables, what thread you're in, all that sort of stuff. It takes quite some time to collect all that information. Yeah, luckily the cool thing is we are writing our shared code base for both platforms, so if you need to debug, you can most likely, if it's an error in the shared code, most likely just run it on Android and debug the same thing there with super debugging support. And then I'd say 90% of the cases fix it for iOS as well by using that information, because it's the same code after all. But yeah, if you really have to fix an iOS specific bug, and we had some of them with the keychain, it's annoying. Okay. Anything else?
Did you consider use the Flutter?
Yes, we thought about using Flutter. I think Flutter is really cool. I have some very good experiences with it. But again, we weren't as sure about the scalability of Flutter. It's not like Jetpack Compose and iOS on Apple and Android respectively, they have full backing from Google and Apple. So we were sure those will be supported in 5 to 10 years as well. Flutter might be dropped if Google decides, hey, Jetpack Compose is the hot new thing. And the second driving factor, and for me that was actually the decision-making factor, is the language. Dart is just not as powerful as Kotlin is. As I said, Kotlin compiles to JavaScript. If we build internal tools, dashboards, whatever, admin panels, we can build them in Kotlin. We can use exactly the same technology. We can use Kotlin for the backend. We can run Spring Boot with Kotlin on the backend. We have superb frameworks. Also easy hiring for that, because Kotlin is widely known. Dart isn't that. Dart is an interesting version of TypeScript, at least how I see it. But yeah, it's not on the same language level that Kotlin is. And that's why we went for that stack. But I think purely on the UI cross-platform consideration, it's a very tough decision. It's a very tough decision. After all, it was the full stack thing that decided for us as a company at that scale to go for Kotlin.
Thank you.
I see you've got a JUnit in there. How's the testing? With the unit testing or UI testing?
It's great. It's great. Kotlin is the declarative capabilities of Kotlin really allow for super expressive tests. We don't use, we use JUnit 5, this one's still JUnit 4 because of the template. But in general, there are a few libraries we pulled in just for having cool assertions written in Kotlin, really declarative. So it's basically something like variable should be 5, and that's the statement, and that's really cool. And yeah, there's not that much more to say about it. So the testing experience is super.
And when, completely unrelated question, but when you were saying that there's a bit of time between, let's say, a new version of Swift comes out and they have to make the bridging headers or
Yes.
call. Are those parts of this open source, or so the community can help build it, or not so much?
I think it's fully open source actually.
The whole thing.
I think so,
Oh,
yes.
okay.
I think it's just one GitHub repository. Yes, it definitely is. I had to think because they archived Kotlin native, but they archived because they moved it to the main Kotlin repository. So it's one GitHub repository, it's fully open source. And I don't know if I got the question wrong initially. You don't have to wait for Kotlin to release a new version if Swift updates, just if you want to access a new feature from the
So
platform.
the APIs or libraries.
Yes, yes. So yeah, that's you would have to wait for that, but I don't think Apple comes up with a lot of new Objective-C APIs anymore.
No.
So until they come up with Swift support for Kotlin, at least that issue we didn't have yet. Okay. Other questions? Yes.
Got one about inline support. So when this all gets binded and converted, and you get a crash stack for through? Is it actually readable, or is it?
It depends on how you go about it. So if you don't do any specifics to Kotlin, no. It just says memory exception, and that's it. But what you have to do is you have to annotate all your Objective-C or Swift-facing methods with add throws annotation, and then it's propagated as an NS error, and you get an error as a stack trace, which is pretty good. And especially if you have debug information included, so if it's a in-development crash, you get a very good stack trace, and in production it's okay. If you have an add throws annotation, if you forget it, that was where Kotlin was laughing, you just get a memory exception, and we have also quite a few of them in our issue tracker, which is just not telling you anything, basically, except for the crash.
Is it compatible with things like crash lyrics, for example?
Yes. After all, it's an NS exception. So all the things that all the tools that can catch Objective-C exceptions and log them, they can also catch those exceptions, as long as you have the add-throws annotation.
So integrating all this Objective-C APIs, you think is like technical debt, or should you just wait, until there's Swift support?
To be honest,
Let's say for like, a company that wants to launch something, next 12 months.
yeah. But to be honest, we didn't need to do too many Objective-C coverings just yet. So the many things are done by Kotlin libraries. So we just pulled in the Kotlin Multiplatform library that does the abstraction for us. The only two things that come to my mind are that we actually really had to dig in and do the Objective-C API and then try to implement it ourselves is accessing a keychain with biometrics, because the biometrics part was missing. Otherwise, there are a ton of libraries out there that already do exactly that for you in Kotlin Multiplatform. But adding biometrics to the mix was making it quite hard. And the second one was we had a case where you needed to switch to a mobile network when doing a request instead of Wi-Fi, even if you're connected to Wi-Fi. Very specific, that needed Objective-C libraries. But I think for these low-level cases, there would not be a Swift binding available anyway. It's you would have to write them in Objective-C because that's the way the Apple framework works right now. Yeah, so we don't, for very big projects that I think is a concern, a valid one. But for us, since we don't have that many native bindings right now, it isn't.
In theory, you could write a Swift wrapper around a Swift-only API and then expose an Objective-C
Yes.
API, and then you could bridge
Yes.
into that, right?
Exactly.
You've tried that. Does that work?
We didn't try, but one of our third parties tried it, and they did just that. Basically, I think a week ago they released exactly that. Yes.
What do you think is the best mixture of Kotlin and Swift, and then after all your experience with it? So, and also, have you explored anything else, like for example, moving a lot of the business logic in the back end, so you don't need to worry about in the front end, and the network layer in Kotlin and the UI in Swift? What do you think?
Well, it depends on how experimental you want to go. If you want to be on the safer side, I'd say do the API in Kotlin Multiplatform, the API layer, the client-side one at least. Do your database in Kotlin Multiplatform. That also works pretty well already. Yeah. And then you could pull in the use cases, like business logic, but in the form of use cases, really focused small things. But then keep the view models platform. That's probably the safer bet you could do right now, because using the view models in iOS is still kind of interesting, I'd say. All these custom things that we needed to build, it works now, but it did take quite some time to get it working, because you need to be able to subscribe to state changes and all that sorts of things, and especially SwiftUI is really opinionated in how to do it with the integration with the combined framework. You can manage to make it compatible with Kotlin, but it took us a while to do that.
And it certainly, I guess that's a good starting point, right? If you
Exactly.
want, to start in the network layer.
That's what I would, if I were to start from scratch in an existing project, I would do network layer and maybe the repository as well. So the client-side caching and everything, but not more than that, and then slowly expanding into the use cases section. And basically trying to pull out the business logic and writing in Kotlin, but step by step, that's how we go. And with the second part of the question, like moving business logic to the backend, absolutely. But that's not Kotlin multi-platform specific, it's more because we can use Kotlin full stack That's what allowed us to do that, because clients and devs really know the business logic and where it lives and how it is meant to be used, even though they're maybe not writing it, but they can read it and they can see it. So that's definitely, we are definitely doing it, but it really depends on how your backend situation is after all.
And sorry, one follow-up on this. And the network layer is the separate module, is a different repo, or is it the same repo?
It's a separate module, but in the same repository. So how we compile, after all, is coming back to the module structure I showed earlier. We have one package that's called mobile, and it compiles many different dependencies into one framework. That's a limitation of Kotlin that you just have to accept for iOS right now. But then we, after that, completely modularized the full code base. So it's really API layers and even separate the features and everything bundled together into one package after all.
Cool. If there's no more question, I think let's end it here. And there's more networking for like another 15, 20 minutes. So Gabriel's there for you guys. Thank you so much.